Okay. So last class we stopped here. So SR to JK. So I told that we'll get these equations. Okay. So have you done this? Have you drawn the diagram? So diagram draw chesara. So we'll see how it will come here. Right. So it is like 8 variable, right? So 1, 2, 3. This is J, K, Q, N, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. Okay. And yeah. So what is the values of S here? So 0, don't care. 0, 0. So 1, don't care. 1,
0.
0. Okay. So this is 1 and this is second pair here. Okay. So what is this value here? So the first one will give a value of J. Correct, na?
So J, Q, N.
J, K, Q, N. Wait. J, Q, N. Correct, na? S gada also. Yeah, 0, don't care. 0, 0. Okay. So 1, don't care. 1, 0. Correct, together. So what is that? So we can do this two only. So why need of don't care here? So we can perform a pair here. Okay. So this will be equal to S is equal to. So what is this value here? So J and the combination of this two will give a value of Q bar N. Okay. So J Q bar N. Is it correct or not? So J Q bar of N. Okay. And what is the value of K? So tell me the value of R here. So R value will be
KQ of N.
KQ of N.
yeah. So this is K. Sorry. So J K Q of N. So the values for R is like don't care 0, don't care 1, 0, 0, 0, 1. Okay. So these two values. So this is 1, 1. Okay. So 1, 1 is nothing but so R is equal to K Q of N. Okay. Now we have to draw the diagram here. So how to draw the diagram? So first of all, draw the SR flip-flop. Okay. So draw the SR flip-flop. Then draw the using AND gates. We need two AND gates here. Okay. So we need two AND gates for the things here. So we'll see that. So SR to JK flip-flop. So draw the diagram and use two AND gates here. Okay, so diagram will be like this. So SR, this is QN, this is Q bar of N. Okay, and here for S, what is the value of S? One input is J. Okay, other input is Q bar of N. Okay, so the input is like Q bar of N. So this is another input, and this is given to S here, and this is K here, and other AND gate. So we'll be using this. So what is the values here? We'll be using the value of R will be like so K Q bar of N here. Okay, so Q bar of N will be like this is the thing here. So this is the Q bar of N. Okay, and we'll be having a clock pulse here. So we'll be using the clock pulse. Clear?
Yes,
Yes,
sir.
sir.
Okay. So this is the JSR2 JK flip-flop conversion. Okay, SR to JK flip-flop conversion. And so, what are the conversions we have seen? So, what are the conversions we have seen? Any other conversions? So, in any conversions, Yusam? So, tell me what are the conversions we have seen?
JK to T flip flop.
JK to T flip-flop. So, whatever the things, so you are clear with this, right? So, conversions which na చేయగలరు కదా ఇంకా.
Yes, sir.
Okay.
Yes, sir.
So now next do the last one, SR to T flip flop. So convert SR to T flip flop. So we'll do it as a last one here. Okay. So SR to T flip flop. So we need a truth table of T flip flop first. We need a truth table of T flip flop. Okay. So T Q of n, Q of n plus 1. Okay. And so what are the values here? So 0, 0, 0, 1. So 1, 0, 1, 1. So t value, if t value is 0 and q of n is 0, it is equal to q of n. If t value is 0, it is equal to q of n here. So q of n is 1. And when t value is equal to 1, it is complement of q of n. Okay. And the values of x and r. So tell me the values of x and r for this excitation values. So 0, 0 అయితే ఏమొస్తుంది? So it's a 0,
Don't care.
don't care. And next one is don't care, 0, correct enough?
Yes, sir.
Okay. So 0, 1 is 1, 0. Okay. And 1,
0,
0,
1.
0, 1. So we need a K-map for this S and R, yeah. So S value for S value T Q of n 0, 1, 0, 1 here. Okay. This is the values of this one. S is 0, don't care. So 1, 0. Okay. So there is a single value. So what is the single value here? So S is equal to J, sorry, this T here.
T T Q bar.
T Q bar of
N.
N. And, so the second one, so this is T Q of N 0, 1, 0, 1, and R is don't care 0, 0, 1 here. So this is only thing here. So R is equal to
T Q
T
of N.
Q of N. Okay. So conversion of SR in the sense. So SR will be having the values here. So this is S, this is R, this is Qn, and this is Q bar of N. So we'll be having a single input here. So we'll be having a T. Okay. So one of the inputs is T. So one of the inputs is T here. So T is given to both the AND gates. Another input is like, so one is having Q bar of N and other one is having Q of N. So that will be the diagram. And clock pulse is common. Clear?
Yeah, sir.
Yeah. So next thing, what we can see here is we'll see the analysis part. Okay, so these are the conversions techniques here. Next, we'll see the analysis part. The analysis part is nothing but we'll be given a circuit, so we have to find the equations for that. Okay, so after finding the equations, so what we have to do here is, so we have to derive the equations for that, and we have to draw the truth table. After drawing the truth table, we have to draw the state diagram. Okay, so you'll know what are those things. So we'll see the analysis part here. So before going to analysis part, so wait. Okay, so we have left with one more topic. The topic is called as master slave circuits. Master slave circuits. We'll see that in next classes. Okay, so far this is the half of the unit is completed. So the half of the unit is like flip flops and all those things. And we are left with one more topic there, master slave flip flops. So we'll see that later. So once we discuss this analysis part here. Okay, so take this diagram. So analysis of clocked sequential circuits. So this is what we'll be seeing here. Analysis of clocked sequential circuits. Take down this diagram. Sit down. అయిపోయిందా? Yes or no?
No, sir.
No, sir.
Yeah. Take it fast.
Power, sir.
Yeah. Everyone done? So what we have to do here is you'll be given a circuit diagram here, a sequential state, and what we had to do here. So what are the steps we had to do? First of all, equations, state equations. We have to find the state equations. Okay, so we have to derive the equation from this, and afterwards we have to draw the truth table or state table. Okay, so it is called as a state table. Okay, so after from the state table, so what we have to find out here is draw the state diagram. So when you are given the circuit, okay, so I'll let you know what is a state diagram. Okay, so when you are given a circuit in your problem, so the problem should be like this. So the problem should consist of the problem should we have to derive the state equations first. So after deriving the state equations, we have to go for the deriving the state table. After deriving the state table, draw the state diagram. So this is the analysis part in most of the cases, and we can do the analysis part with three kinds of flip-flops. So we'll not use SR flip-flops, so we'll be using D flip-flops, JK flip-flops, and T flip-flops. So these are the three circuits which are used to perform the analysis of the sequential circuit. So analysis is nothing but, so we'll be given a circuit and we have to analyze that circuit. So that is the meaning of analysis here. Okay, you'll be given a circuit and the analysis should be done here. Okay, so that is what we are going to see right now. So first of all, we have to identify the equations here. So three possible equations. We have two flip-flops here. So that is A flip-flop, this is B flip-flop, and we have output Y here. They have output Y. So what of all, first of all, what I need is like A is nothing but, so the output of the first flip-flop, B is nothing but the output of the second flip-flop. So what I can say here is, so I need to find the next state equation of A of t plus 1. Okay, and I have to find a B of t plus 1, and I have to find the value of Y. Okay, I have to find the value of Y here. So check the circuit there. So check the circuit. So in that circuit, okay, so what is the value of, what is the function of D flip-flop? So what is D flip-flop generally? So D flip-flop ఏం చేస్తుంది? What is the property of D flip-flop? So what is D flip-flop? What is the equation of D flip-flop?
D is equal to Q of n plus 1.
Q of n plus 1, sir.
Yeah, D is equal to Q of n plus 1. So our Q of n plus 1 is equal to D. Okay, so here A of t plus 1 is equal to D. So what I mean to say here is, so A of t plus 1 is equal to D. So Q of n plus 1 is equal to D is the state equation. Okay, A of t plus 1 is equal to the state equation. Yes or no?
Yeah, sir.
Okay, so since instead of Q of t plus 1, I'm using A of t plus 1 here. Okay, and what happens here is, so here A of t plus 1 is equal to D here. So what is the value of D? So D is getting input from an OR gate and two AND gates. So what is the OR gate here? So OR gate is getting input from the two AND gates. So what is the two inputs here from AND gates here? So this is A and this is X here. This is X. Okay, so XA plus, okay, and this one two AND gates. This is also X here, and what is this one here? So what is this one? So this is the value of B.
B.
Okay, so it is AX plus BX. Okay, so A of t plus 1 is equal to AX plus BX. So next, check the value of B of t plus 1. Check the value of B of t plus 1. So what is the value of B of t plus 1? So tell me the value of b of t plus 1.
X A bar.
X a bar. Yes or no?
Yes, sir.
Yeah, sir.
Yeah. So we can check that it is nothing but the x a bar. Okay. So this is x here. Okay, and this is a bar. Okay, so b of t plus 1 is equal to so a bar x. Okay, and coming to y here, so what is the value of y? So what is the value of y? What is the value of y? It is a multiplication of. What is the value of y?
A plus
X bar into A plus B, sir.
X bar into A plus B, sir.
X
X bar into
A plus B.
a plus b. Okay, so that is a three equation. So that is the first thing we have to do. Okay, so the first thing is nothing but so these are three equations. A of t plus 1 is equal to ax plus. Okay, so ax plus bx. So instead of t, I'll be using this ax plus bx here. So this is a bar. This is a bar value. It's a mistake there. So a bar of x here, and what is this value here? So a plus b into x bar here. So you can check here. So this is what is this value here? This value is this is x here. Sorry, this is so what is this value? We are getting this value from b here. B plus. So what is this value? A. So a plus b into x bar. Okay. So a plus b into x bar. So this is multiplication, right? So 1 gate is multiplication. So it is nothing but a plus b into x bar. So we got these three equations. So any doubts in this?
No, sir.
No, sir.
Okay. So we got this outputs here. Okay. And so what we have to do right now is so 1 minute. So next we have to draw the state table here. So the meaning of state table is right. So we have to. So what we have to do here is so we have to draw the state table. The state table should consist of all these things. Okay. So the state table should have all these things. So what are those things? Present states. The present states are nothing but so a of t generally. Okay. So a of t and b of t. So these are the present states. Okay, and inputs, that is x. We are having the inputs of x here. Okay, and next. So what are the things we have? So we have next states is nothing but a of t plus 1, and we have to write b of t plus 1. Okay, and outputs. That is output is equal to y here. Okay, so this is what we should have here. So the state table should consist all these things. Okay, so what are the things we should have here? So what are the things we should have? So we should have inputs here. So present states. Okay, so what are the present states here? The present states are nothing but so a of t and b of t. Okay, and so what is the next state here? Sorry, inputs is here. Inputs is nothing but so this is input here. and the present state. This is present state. The present states and inputs will give the next states. So next states are nothing but a of t plus 1, okay, and b of t plus 1 are the next states. This is ns next state, and this is the y is the output here. Y is nothing but the output. So clear about this?
Yeah, sir.
Okay, so this is the state table, and when we get the equations, what we have to do here is we have to substitute those values. So we have present state and inputs will give the next state. So present states and inputs, a combination will give the three inputs, I mean three variables here. The variables ranges from 000 to 111, and all these a of t, b of t, and x values are substituted into the a of t plus 1, b of t plus 1, and y values here. So from this we'll get the values of a of t plus 1, b of t plus 1, and y. Clear?
Yeah, sir.
Okay, so that is what we have to do right now. So in case of analysis part, this is in case of D flip-flop. So D flip-flop is quite easy. It's quite simple because input is output and output is input in case of the D flip-flop here. Okay, so this is the state table. So how did we get this state table? This is the present. Am I audible?
Yeah, sir.
Yes, sir.
There is a power cut here, so I connected to my mobile internet. Okay, yeah. So this is 1 minute. So this is present state. Okay, so that is a of tn అనుకోండి, b of tn normal a b x అని రాసుకోండి, and this should be how should it should be the state table here. Present states and inputs here, okay, and next state nothing but a of t plus 1, so b of t plus 1, and this is the output here. Substitute these values. So what are these values here? The combinations what we have taken from 000 to so 111, okay, 000 to 111. So these values are substituted in the equations here. This is what we'll get here. Okay, so substitute these values. The table is going. So substitute this. You note those values. Okay, so these values should be substituted into the equations. So what are these equations? So the equations are a of t plus 1 is equal to ax plus bx. So ax plus bx in the sense a is 0 first, b is 0, next is 0 initially. So hence the value of a of t next state is equal to 0 first. Okay, same case for b of x here. B of t plus 1 is equal to a bar x. So that is substituted here, and y is equal to a plus b into x bar. Okay, so these values are substituted here. So substitute these values and note these equations. So I mean, substituting these values in the equations, what we get will yield these values. Clear?
Yes.
Yes, sir.
Okay, and so the next things are like what we have to draw here is we are done with state equations, we are done with the state table. Okay, so state equations, these are the state equations, and this is the state table here. Okay, next we'll go for the state diagram. Okay, so we'll go for the state diagram. So how to draw the state diagram? Okay, so state diagram will be like this. Okay, so state diagrams will be like this. So whenever I draw the state diagram, I have to check the present states here. Okay, so check the present states. So present states ఎన్ని ఉన్నాయి మనకు, ఎన్ని kinds of states ఉన్నాయి, present state check చేయండి. So what are the present state values, what are the number of possible states here? So what are the maximum number of possible states? ఎన్ని possible states ఉన్నాయి మనకు ఇక్కడ? So check the present states here.
Eight, sir.
So 8 states, 8 possible states ఉన్నాయా?
4, sir.
4,
4.
sir.
Yeah, so 0 0 is one state, 0 1 is another state, so 1 1 is another state, and 1 1 is, sorry, 1 0 is another state, and 1 1 is another state. So we have 4 states here. Yes or no?
Yes, sir.
Okay, so so what we have to check here is, so we have to draw a state diagram here. That state diagram, the first step it has to do here is it has to list all the possible states. We have to list all possible states. So what are the all possible states here? So 4 possible states. Okay, the 4 possible states are, I'll mention them as 4 possible states. So 0 0, 0 1, so 1 0, and 1 1. Okay, so this is the 4 possible states here. Instead of writing the values here, so what I'll do, so I initialize the values here. S0 is taken as 0 0, S1 is taken as 0 1, so S2 is taken as 1 0, and S3 is taken as 1 1. Okay, so I'll write like that. Okay, so clear. So state diagram, so diagrammatic representation of a state table. Okay, so I'll write like this. S0, first of all, the first thing is list all the possible states here. Okay, list all the possible states. So 4 possible states. So we have 4 possible states here. Okay, so next, list all the possible transitions. Okay, so transitions in the sense, so from one state to the other state. So when we have in the present state, so an application of input, so what is the next state? Okay, for example, if S0 is, what is meaning of S0 here? So what is meaning of S0?
0 0.
What is meaning?
0, 0, sir.
0 0. S0 ki input 0 iste emoutundi. What is the next state here? So what is the next state?
0 0.
0,
0 0. When input is given as 0 here, the next state is 0 0. The meaning of 0 0 is nothing but it remains in the same state. It's not state lone untundi. Okay, so this is the diagram here, and input is x here. Okay, and what is output here?
0.
So inputs and outputs. So the diagram should be like this. So this should represent input, and this should represent output here. Okay, so this should represent output. Clear?
Yes, sir.
Okay, and from S0 to, if input is given as 1 here, if input is given as 1 from S0 state here. Okay, so what happens? What is the next state here? What is the next state? What is the next state when input is 1?
0, 1, sir.
0 1 ante
0, 1, sir.
what is the meaning of
Yes,
0
sir.
1? So I given the names, right? S0 is equal to 0 0. So S1 is 0,
S1, sir.
S2 is
S2 is 1,
0,
0.
S3 1 1.
1,
So if
1.
it's 0 1 ante it is S1.
Yes, sir.
Okay.
S1.
So it will move from S0 to S1. So when input is applied is 1 here, and what is output here?
0.
0.
0. Okay. So draw like this. So arrow mark 0 here. In the same way, from 0 1, if input applied is 0, it will go to the state 0 0. Okay. So this is S1 nunchi. If input is 0 applied, okay. If I apply an input of 0 here, okay, and the output is, what is output here? Output is equal to 1 here. The output is mentioned as 1. From S1 it goes to 0 0 when input is equal to 1. Sorry, input is equal to 0 here. Clear?
Yeah, sir.
Yes, sir.
Okay. And coming to the next one, it is like, it is also S1. When input applied is 1, it will go to the state 1 1. So 1 1 is nothing but S3.
S3.
Okay. So 1 1 is nothing but S3. So what is the input applied here? So generally ఇక్కడ S2 తీసుకోండి, ఇక్కడ S3 తీసుకోండి వీలైతే. Okay. So S2, S3. So S1 2. So I'll go to S3. So when input is equal to 1, and what is output here? So output is equal to 0. Clear? So అర్థమవుతుందా స్టేట్ డయాగ్రామ్ ఎలా డ్రా చేయాలో?
Yes, sir.
Yes, sir.
Okay. So this is how we draw. So I'll show you here. Okay. So this is 0 0 అని రాయొచ్చు, లేకుంటే S0 అని రాయొచ్చు. Okay. So this diagram is like this. So before going to that, mention them as 0 0 only. Okay. This is S0, this is S1, this is S2. So we can take in different ways, but we have to mention the transitions correctly. Okay. It will remain in the same state. So this will represent the input and this will represent the output. Okay. So input is X here and output is Y. Okay. And these are the states A, B here. So next states are nothing but, so these are the values here. Okay. Clear or not?
Yes, sir.
Okay. The
Clear,
state
sir.
diagram will do this. So what is the function of state diagram in the sense? The state diagram will list out all the possible states. Okay. So list all possible states. So what are the all possible states? We have 4 possible states here. So first of all, list all 4 possible states. All possible states. Okay. And second, this list all possible transitions. List all possible transitions. Okay. Transition, the meaning of transition is nothing but on application of input, the change of the state is called as a transition. Okay. The change of state on application of input is called as a transition. Clear?
Yes, sir.
Yes, sir.
So take this diagram as state diagram. So we are done with state equation, state table, and this will be the state diagram. So take note the state diagram.
Yes, sir.
Okay, so this is how we have to do the analysis with D flip-flops. So when you are given D flip-flops, this is the straightaway can follow this method. Okay, so with JK flip-flops, it is a little bit different. Okay, so it is a little bit different. So next, you draw this diagram. So take down this diagram. So we have to do the analysis part here. So we'll do the analysis part for this diagram. So do this diagram, and first of all find a state equation. Afterward, take this diagram.
Yes,
Okay, so
sir.
find state equation. So find state equation. So I have only one flip flop here. So A of t plus 1 is equal to A of t plus 1 is equal to. So what is the values here? We are using XOR gates here. So A XOR X XOR of Y. Yes or no?
Yes, sir.
Okay, so we have options here. So A XOR of X XOR of Y here. Okay, and so this is the only state here. So only state here. So what is the state equation here? So what is the state table? State table. Okay, so state table is what's the state table should have here. So first thing is like it should have the present states. Okay, so what are the present states here? We have only one present state, that is A of t plus 1 and A. Okay, and what are the inputs available here? So what are the inputs?
X, Y, sir.
XY, sir.
X and Y. So present state is A. So inputs are X and Y. Okay, inputs are X comma Y here. Okay, and so we have three combinations here. So present state and input is a three combinations. When it is a three combination, so what we have to do here is, so we have to write all the possible combinations like 0 0 0 0 0 1 0 1 0 0 1 1. So 1 double 0. Okay, so 1 0 1. So 1 1 0 1 1 1. So 8 combinations are possible because we have two inputs and a present state, one present state here. Okay, and next what we have here, so next we need so next stage, so we have only next stage, there is no output column here, so we have only next state here. Okay, so we'll be having so next state I'll put it as n of s here. Okay, and a of t plus 1. So substitute those values in the equation. So a xor of b xor of, okay, so a xor of b xor of, sorry, a xor of x xor of y. So what is the value here? So what is the value? XOR operation చేయండి. So what are the values we get here? 0 XOR of 0 0 0 XOR of 0 0 0 XOR of 0. Okay, 0 0 XOR of 1, it's a 1. Okay, 0 XOR of 1, it's a 1. 1 XOR of 0, it's a 1. Okay, 0 XOR of 0, it's a 1. 1 XOR of 1, it's a 0. Because I am substituting these values in the equation. Above what are the equations we got? I am substituting those values. So 1 XOR of 0 is a 1 and 1 XOR of 0 is a 1.
1.
So, huh? So 1 XOR of 0 is a 1 and 1 XOR of 0 is a 1 here. So 1 XOR of 0 is a 1, 1 XOR of 0, 1 XOR of 1, it's a 0. Okay, so 1 XOR of 0 0 0 XOR of 0 0 here. So 1 XOR of 1, it's a 0 0 XOR of 1 is a 1.
1.
Okay, so this is what we'll get here. So this is the state table. Now what we have to do here is we have to draw the state diagram. Okay, so we have to draw the state diagram. Okay, so how to draw the state diagram? So we can draw the state diagram. So what are the number of possible states here? So first of all, we have to list all the possible states here. So what are the possible states here?
4, sir.
0 0.
The possible states is 4. How come 4?
2, sir.
2,
So
sir.
only two states. So check only the present states here. Present states low ఏదైతే possibility ఉంటుందో we have only one present state. I mean a possible state a ఒకటే ఉంది. When it is 1 we have two possible states here. The two possible states are 0 and 1. Okay, so one is 0 state. Okay, other one is 1 state. Okay, now we have to list all the possible transition here. In 0 state, the application of input is, okay, the application of input is 0 0. Okay, there is no output here, so there is no output out. I am not mentioning anyone. 0 0, it will remain in the same state. Okay, and if in 0 state the application of input is 0 1, it will go to the state, it will go to the state 1. Okay, an application of input 0 1. Okay, and if it is like 0 state, the application of input is 1 0. So comma, I'll put it as a comma here. So 0 1 aina 1 0 aina, it will go to the next state here. And if it is 1 1, it will remain in the same state. Okay, so this is with relation to 0 here. And coming to 1 here, so 1 state. Okay, if it is like 0 0, it will remain in the same state. Okay, so a of t plus 1 1 and it is the same state. If it is 0 1, it will go to the 0 state. 0 1, it will go to the 0 state, and 1 0 also, it will go to the 0 state. And if it is 1 1, it will remain in the same state. So this will be a state diagram. Clear?
Yeah.
So clear or not?
Yes, sir.
Yeah. So this is the state table. I mean, this is analysis using with the D flip flop. So we'll see more analysis to come. Okay, and so using D flip flops, JK flip flops, we'll see it in the next class. Okay. So meanwhile, we'll see with the D flip flops only. So we'll see one more problem related to D flip flop. Okay. So D flip flop analysis is very easy. So compared to other flip flops. So what we'll do, we'll stop for today to this session. Okay, so you just understand these concepts. Okay, and if possible, we'll see in the evening class. Okay, if possible, we'll see the evening class. So we'll see all the analysis part. Okay, analysis part. Shuddhamu. Okay, so we'll see one or two examples of D flip flops only. Okay, so first of all, D flip flops aర్థమైన తర్వాత I'll go for JK flip flops or the next one. Okay, yeah, this is what we have done. So introduction, latches, RS and JK flip flops, RS, JKT and D flip flops. So master say flip flops, H triggering flip flops. It is a simple concept, but I'll let you know later. Okay, and flip flop conversions we have done. Okay, so with this second unit is almost done. So only one topic is left. It is a matter of half an hour, but I'll explain you after this third unit. Okay, and we are left with one more topic, that is memory decoding. So memory decoding unit type in the Japan. Okay,
Okay,
so
sir.
analysis and design of sequential circuits here. So we are doing the analysis part right now. Okay, so after once the analysis is done, we'll do the design part. We'll go for the design part there. Okay, so we'll see the analysis first, next we'll go for the design. Clear?
Yes, sir.
Yeah. Drop your attendance and we'll stop for today.